In this video, I'm going to talk about one of the apply functions, which is tapply, and then split function. And at the end, we will combine these two functions. So let's start with tapply function. When you just write tapply in R, you will see that you should first give a data in here. And then your second argument is index, which is you should tell how to group the data before the function is applied in here. Okay, and we have these three arguments, and you can just write any function you want in here. First of all, we will upload a data, and we are going to use this data set. It's an airline data. It's in CSV format and 2008.csv. So when it is uploading the data, let me go to the website and show you the data set. Let's see. Here is the data set. Excuse me. And this is an airline data set. Comes from Rita originally, and actually it was here before, but now they put it in Harvard Dataverse. So let me first talk about the variables, and you can find the year, month, day of week, and departure time, which is important for us. It is actual departure time. And then we will use maybe tail number, plain tail number in here. And also departure delay, it's an in minutes, and you can see the departure delay of that flight, and we can see the origin. And these are all in airport codes. And actually this is the data from US. And you can find the years from 1987 to 2008. And it's kind of a large data set. And when you try to download all of them, and I think it will get maybe like, let's say how many gigabytes, maybe 5 gigabytes in here. I haven't tried it, but I know this is 450 megabyte, maybe one of them. And it's kind of a large data set. So if you want to get the data, for example, for tapply function, we will use the 2008 year, and you can just get this data from Harvard Dataverse, dataverse.harvard.edu. And then you see that every other year during statistical meetings, they use one data set in the computation. And this data set is used in that computation in 2009. The name is Data Expo. And if you want to find the data sets in here, you can just see them. You see one of them is 12 megabytes. And yeah, I just said it 450 maybe. And this is the zip files. And when you just unzip them, it's going to be bigger, I guess. And let's see if I write 2008 and just find the data. Let's say where is it? Where's my data? I can just find the data in here, I guess. 2008. Let's go more. I think the website is not working now. Let's run it one more time. And when we go back, I will show you 2008 database. And here is Dataverse Harvard data. If I just say 2008. Okay. Now we are able to find the 2008 data in a zip file, and you can just click and download and just unzip the data sets. So while we are looking at the data, I think R already read the data in there. Let's see. Yes, so now we are able to see the airline data in here. And if I just say head of just call the head of the data. And here is the first 6 lines. You can see we have year, month, and all the variables. Let's check out for the dimension. I think it was 29. Yes, we can see all the 29 variables in here. And also, let's see, you want to see the departure delay of this data set, airline. Let's see, I want to just check out for departure delay. For the first 6 ones, we have, like in the first one, we have 8 minutes departure delay. We have 19, and I think this is -4, maybe wrong in here, and we have 8, we are 34 and 25. And also we can check out for another variable, airline, let's say origin, and you see for 6 origins in the data. If you want to see all of them, let's try, but I'm not sure if it's a good idea. Yeah, it's not showing you all of them, but still we can see the first 1000 line in here. So let's say you want to calculate the mean of departure delay by origin. Now we are familiar with the data sets. We know the departure delay and we know origin. And let's say you want to find the mean of departure delay by origin in here. So maybe you want to save it to an object. Let's say it's delay mean. And I'm going to use tapply function. And first of all, I will give my data in airline departure delay. So in my airline data, I want to use departure delay. So I want to group data by airline $sign origin in here. Okie dokie. So my function can be anything. Let's say I want to use mean, and I can add more options after that. Let's say I want to remove NA values. If you just say NA.rm true, then it's going to remove the NA values. You know that mean is not working with NA values. So when you run this part, it just get a second to run this part. Let's see the first 20 line of this departure delay. You see that from, for example, from ABE, you can see this is the mean of the departure delays in the year of 2008. Okay, and we can repeat the same calculation for, say, one of the other variables. Let's say tail number, for example. Let's say delay mean 2 in here. And again, I'm going to use tapply function. My vector is, again, this variable. And this time, instead of airline origin, I want to use airline tail number. And again, I can use mean or any function you want, NA remove equals true. And when I run this one, it just takes seconds to run. And I want to see the first 20 lines in here. Okay, these are the tail numbers, and I'm able to see them. So we are able to calculate them for more than one variable too. You see that we were using just one variable in here. Now also we are able to use more than one variable, which is kind of cool for tapply function. For example, we can calculate the departure delay for both origin and destination. And let's say I will find the result. I will save my findings in results. Let's use again tapply function. In my airline data set, I want to get this departure delay. This time, instead of one, I want to use 2 variables. You can just use list function in here to use 2 variables. And one of your variable is just airline dot please remember we were supposed to use origin and also airline data, and I want to use destination. Here is my destination. And my function is again mean. I want to find the mean of departure delays in 2008 in this data. NA remove is true. So please note that there are many NA's values now. And I just run this part. If you want to see the head results and NA, what's the NA? So 20. So you will see lots of NAs in here because there will be no flight from all origin points to all destination points, okay? So also results are recorded as state codes on rows and columns. You can see the state codes in here, okay? For example, there is, let's see, there is no flight from ABI to ABE, for example, okay? Then you can just find NA values. And you can just give a particular state and just try to see there. Let's see, I want to get Indiana, and IND is the code for Indiana, and ORD, which is Chicago O'Hare International Airport, which is the code for that one. When I just run this part, you will see the flights from Indiana to Chicago has averaged 16 or 17 minutes and in 2008, okay, 70 minutes departure delayed in that year, in that particular year. Also, we can check out the results for multivariate case in here. I have my results and I want to combine my departures and origins in here. Let's use several inputs. I want to use Indiana airport, and we already know ORD, which is Chicago, and we want to use CVG, and this is Cincinnati Northern Kentucky International Airport, and we can use MDW, which is Chicago Midway. Okay, I want to use the same for destination, and when I run this part, you will see we have NAs on diagonals because there's no flight from Indiana to Indiana, of course. And so the average of the departure delays in 2008 from Chicago to Indiana is almost 16 minutes. And there is no flight from, let's say, Cincinnati to Midway. And these are NA values for that particular airport. And from MDW, we only have flights to Indiana in this group. And the average value is 14, almost 14 for departure delay in 2008, okay? And this is how can we combine some variables and just group that variables and use them for a particular vector or particular data in here for a specific function. You can just use whatever you want instead of this mean function, okay? And this is all I wanted to say about tapply function in here. Let's say tapply. So this another function I just want to show you is split function. So by using split function, you can easily split your data, and this function takes a vector or other objects and splits it into groups determined by a factor or list of factors, okay? And so we will simulate some data and split it according to a factor variable. And in here, we are going to use GL function, which is for generate levels, okay, in a factor variable. So let's first generate some data. I want to generate some data from normal distribution, 10. And from uniform distribution, let's say again 10 variables. And again from normal distribution, 10 and different meaning here. So here is my X data. So I have 30 variables from two different normal distributions and 10 from uniform distribution. And let's generate a factor. You can generate it by using GL, which stands for generate levels. Here is my function. And you can just give 3 and 10. Let's see what's happening. And here is my F. And it's just generating me 3 levels. And there are 10 for each level. Okay, we have 10 values. And these are levels that we are generated. We have 3 levels and 10 for each of them. So if you want to split your data, let's split your X by F. So you are going to split your data by these 3 guys. Here is your data sets. In the first one, you have 10 of them. So this is your first level. And the corresponding first 10 is going to be in your first level. And this is your second level and your third level. So you split your data and you can even use your lapply or the other apply functions just for combining to apply some functions in here. Let's say I have my lapply. I want to give a list. Let's give this one. Here is my list. And my function can be mean. So for each level of this X in here, it's going to find the mean values. That's kind of easy. And we can use the same functions for a data frame. And for this example, we are going to use library data sets. Here is my library. And let's see one of the data, which is air quality in data sets, which let's see the head of them. And so here are the variables. We have ozone and solar are wind, temp, month, and day. Okay. And if you want to see more about this data set, let's write air quality. And you will see that this is just giving you the daily air quality measurements in New York from May to September in 1973. And we have some variables, like 6 variables for 153 observations in here, okay? Let's assume that you want to split your data sets. You are kind of familiar with variables right now. Let's say I want to split the air quality data frame by the month variable to have separate sub-data frames for each month. And I can do that by using split function. I have my S. Now I'm going to use split air quality. Here's my data sets. I want to split it for air quality month. And when you run S, or when you just str, it's going to be easier to get the idea. And you see in str, and you are just splitting your data by month. Of course, there are several ways to split your data. You can even use different functions in here. And now you have your list of 5. This is the 5th month. And for each of your variables, we are able to see their structures in here. This is for the 6th month. And this is for the 7th month, which is July. And we have August and we have September, okay? And now we are able to see all of them. Now by using an apply function, we can just find the column means, okay? This is just combining an apply with this one. Apply, and I'm going to use S. Here is my S. And in here, I want to generate a function of X for each of it. What happened? So in my function, let's say I want to get column means for my variables. Let's get not all of them. I will just choose some of them in here. For columns, first add comma. And we have, let's say, for ozone variable, and also for, I think it was solar.r, we can see it there. And also I want to get the column mean for wind too. Here are my examples in here. And when I just run it, oh, I have incorrect number of dimensions in here. Okay. Let's say I have my S. I'm going to use a function of X. And we want to get the call means in here. We have X. And we are using combine of ozone, solar, wind. Why it's not working? Everything is okay, I guess. Huh? Let's just, I don't know what happened. Ah, okay. I think I did some typo there. So for the fifth month, and we can just find the wind and what happened in here. Why do we have NA values in here? Maybe we don't have this. Ah, okay. So we have some NA values for our column means. You see, we have NA values, and when we have them, it's not working in here. Okay, please be careful in there. Maybe you can just try something different in here. Okay, just try to find your own way, maybe better way for your call means. And so if you try sapply instead of lapply, let's use sapply. I think now it is like in a clear manner. You see, now we have a matrix instead of a list. Now for each month, we have the mean values for these guys in here. Okay. So how can we make it, how can we remove these NA values is that we can add like NA remove in here, similar to the previous examples. Just add NA remove as true, true. And now just it's removed NA values and calculated column means for us in here, okay? I think this is all I wanted to say about tapply function and split function, and we kind of combine these lapply or some apply functions for split functions in this video.